Yeah, good evening all. Online students, is my voice is loud and clear? Okay. So in the last class, we are discussing about the statistics and let us continue with the same, right? So in the statistics, we have seen some kind of distribution and probability distribution and frequency distribution, cumulative frequency distribution, and all these things. Now, in today's class, we are going to continue from there within the statistics and we'll try to cover the complete descriptive statistics by today. And okay, guys. So here is the statistics. So within the statistics, we have covered in terms of measures of central tendency, measures of dispersion, and also with respect to percentiles, quartiles, outliers, upper limit, lower limit, and all these things, and along with the histograms, right? And what is meant by normal distribution, all. Now, so here we are having the third type of measure is called as skewness. Okay. Now, till now we have covered the measures of central tendency where mean median mode is there. And after that we have covered in terms of next one called as measures of dispersion or measures of spread. And now we are moving on to the third one is called as measures of shape. Okay, measures of shape. What is this measure of shape is called as skewness. What is meant by skewness means if skewness value is equal to 0, it is called as perfect normal distribution. If it is called as perfect normal distribution or which is symmetrical distribution. Already I told you what is normal distribution. Normal distribution means symmetrical distribution. Symmetrical distributions are called as normal distribution. Now, if the skewness is equal to 0, it is called as perfect normal distribution. If skewness is less than 1, if skewness is less than 0, simply to say less than 0, that is negative value. If skewness is less than 0 or skewness is negative, if the skewness value is negative, if the skewness value is negative, in that case, it is called as left skewed distribution. Left side skewed. Left side skewed means what is the meaning? Left skewed means left side you are having the less number of values. It is a left skewed distribution. Okay. Now, if the skewness, what are the skewness is there? If the skewness is greater than 0 or if the skewness is positive, it is called as positive skewed data or which is also called as right skewed data. Positive skewed or right skewed. What is meant by right skewed? Right side less number of values. If you are having left side less number of values, it is called as left skewed. If you are having right side less number of values, it is called as right skewed. Point is clear? Now, this is a measure. Now, so we are going to calculate. See here, how this will be calculated means by using the formula. For sample data, whenever you are considering a sample data, we are going to calculate this one. Okay, what is the formula means? N divided by n minus 1 into n minus 2 into sigma of x minus x bar whole cube divided by s cube. X minus s bar whole cube divided by s cube. That is the formula for the this. Now, what is this meaning is, for example, if you want to calculate the skewness for this particular column, X, let us assume this is the X. First, what you have to calculate means, first you have to calculate the X bar. This is the X. First, you have to calculate the X bar. After that, you have to calculate X minus X bar. After that, you have to calculate X minus X bar whole square. After that, you have to calculate X minus X bar whole cube. Now, for this X minus X bar whole square sum means for this particular column, what are the values you are having? You have to do the sum. Divide by n minus 1 square root of. This is called as S. You will get the S from this column. After S was calculated, now S minus X bar whole cube also 5 values will be there now. Again, you do the sum of this one. X minus X bar whole cube. Do the summation. Okay. Now, finally, the skewness. What are the skewness value is there? The skewness is equal to n divided by n minus 1 into n minus 2 into sigma of x minus x bar whole cube divided by s cube. So, you are having the s value. You are having the sum of x minus x bar whole cube value. N values, everything are available. So, like this, you are going to calculate. Point is clear? Yes or no? Sum of x minus x bar whole cube means first you have to calculate the x minus x bar whole cube for that particular column sum. This is meaning is for this particular column sum, not for individual value. Okay. Why? Because x is not a single value now. X bar is a single value. What about x? X means 1, 2, 3, 4, 5. If you substitute 1, you will get a different number. When you substitute 2, you will get a different number. When you substitute 3, you will get a different number. Is the point is clear, everyone? So, just you are going to calculate the sigma of x minus x bar whole cube from this particular column. And using this column, you are going to calculate the standard deviation. And from that, you are going to calculate the skewness. Clear, everyone? So, this is the measures of shape. Now, if the skewness, what are the skewness is there? If the skewness, here, just observe, this is the data. Okay. Now, in this data, I am going to ask df of, yesterday we have done. If you remember the same example, I asked it to take the photo of this data also, right? Now, if I take the df of first column, I am going to consider the column name. What is the column name is X. And for this particular column, I am asking the skewness dot skew. What is the value? Dot skew is going to give 0. What is the meaning of 0 means normal distribution. Yesterday also for X, you will get the normal distribution. Now, similarly, if you go with the Y, next column name is Y. Now, yesterday open your notes and for Y column, I asked it to draw the histogram. You have written already for Y column. For Y column, what is the histogram? What is the output you have got for the Y column histogram? It is a right skewed. Right skewed, which is nothing but positive skewed. Can you see here number 0.69. Third column, Z column. Yesterday I asked you to draw the histogram for the Z column also. Last column. What are the Z column you are having here? Z. And if I ask the skewness, I am going to get the minus, which is called as negative skewed. Even histogram also says the same. Skewness value also says the same. So, to check whether the given data is normally distributed or not, to check whether the given data is normally distributed or not, whether it is a normally distributed data or not. This is the question. To check whether the given data is normally distributed or not means For this, you are having the multiple options. Option number 1. Option 1, using the histogram. From histogram also you can say, using the histogram, which side more amount of data is there, which side less amount of data is there also you can say. Second, option 2. Okay, option number 2. By using the KDE plot. Today we are going to discuss the next plot is called as KDE plot. What is KDE plot means? Kernel density estimation. What is this KDE plot? I'll explain. In a few minutes you will understand. After this, option 3. Option 3, where you are having the, by using in terms of skewness value. Skewness value, based on the skewness value. Option 4, based on the mean and median value. Based on mean and median values. Using mean and median values also we can say. Using mean and median values, we can say whether the data is left skewed or right skewed or normally distributed. Total 4 options are there. Okay, you can choose any one. Out of which one is best one means skewness is the best. Directly will give the value wise. Okay, you want to present to others means plot wise we are going to represent. Now, first already I told you skewness wise. How to check the skewness wise? Based on the skewness value, how you are going to say whether the data is normally distributed or not means like this. If the skewness value, what are the skewness value is there? If the skewness is 0 or less than 0 or greater than 0, based on the skewness value, that is option number 3. Okay. Now, coming to the option number 4, which is mean and median. How we are going to say using the mean and median means, okay, if mean is equal to median, if mean and median both are same, it is called as normal distributed data. Is the point is clear? If mean value is less than median, mean value is greater than median, it is called as left skewed. Okay, sorry, mean value is less than median, not greater than median. Mean value is less than median. Mean is less than median, it is called as left skewed. If mean is greater than median, it is called as right skewed. Okay. Now, using the mean and median also we can say like this. How, sir? That we'll discuss one by one. I'll show you. First, let's start here. Let's take one column. Here total 3 columns are there. Na? Let us take one column, and for one column, let us apply all of them. 4 options let us apply, each and everything. So, let us start with the first column called as X column. Okay, I'm going to show you for the X column. I'm considering here, let's take the X column. Heading I'm going to give as X column. For the X column, first I'm going to show you what is the option 1 I told you, skewness. Option 1 is called as skewness. Okay. And option 2, what are the option 2 is there? That is based on the mean and median. So you just to give the numbering like this, what are the options are there? This you bring the option 1, this you give as option 2, this you give as option 3, and this one you give as option 4. In these 4 options, I'm going to explain one by one for you. Where 2 of them are measures, 2 of them are plots. Okay. Now using the mean and median, so just I'm going to take here df of x. What are the df of x is there? Dot mean, first value, second value, comma, df of x dot median. So it is going to calculate the mean value and median value. What is the values you have got? First value as 35, second value as 35. Since both of them are same, what it is called as normal distribution. Clear, everyone? Now, what is the third option I told you? Option number 3 is called as histogram. Let us draw the histogram. How to draw the histogram is SNS dot hist plot, and for which column I want to apply this one, I have to write that one along with the bins is equal to 7. Something, the bins I am writing here. Now it is asking what is SNS. I am going to execute on the top only. I am going to import the SNS, I mean Seaborn as SNS. Right? Now, first one, okay, X column. So now when I'm applying the histogram, can you see? This is a normal distributed data. For X column only, option 1, option 2, option 3. 3 options I have completed. Now for X column only, I'm going to apply the fourth option. What is that option is called as KDE plot. SNS dot KDE plot on DF of X column. And I'm going to get the KDE plot like this. This is the curve. Now what does this curve mean? Now this curve is nothing but just it is going to attach the values in this way. Okay, just it is adding like this edges. What are the edges are there now? The edges of the bars are added. Right now, so here what are the values are there? Kernel density estimation. What are the kernel density estimation you are having? This is the curve. And in this curve, what are you seeing the curve? If for the curve, just observe from the center. Center means this one. From the center, whether both the left side and right side both are same? Yes. So it is a normal distributed data. This is also called as bell curve. So normal distribution data is also called as bell curve distribution. Bell curve. Because it is looking as a bell type. Is the point is clear? 4 options are clear? Done? Now, let's move on to the next one called as Y column. We have completed for X column. Now let us take the Y column. That is df of Y. First, for Y column, let's apply the first one called as skewness. Okay, I'm considering here Y column now. First, I'm going to take the skewness. And what is the skewness I have received means positive skew from the skewness option. What is the second option I told you? Mean and median. So I'm going to calculate the mean value and along with the median value. And what is the mean and median? Mean value is 30.125, median is 28.5. And which one is highest, mean or median? Mean. When mean is greater than median, what type of distribution it is called as? Right skewed. From the skewness also it is saying it is a right skewed. From this one also it is saying it is a right skewed. Both are giving the same answer or different answer? Is the point is clear, guys? Now let us try with the third one. What is the third one? SNS dot hist plot, where I'm going to give the column as df of y and bins is equal to 7. Now, and as per the histogram. Now, sir, earlier you told that mean is greater than median. Okay. Now, just tell me, guys, for this case, what is the mean value? Mean value means where it will be there? Obviously in the center. This is going to be the mean value. Always mean is called as center value. What about the median? So here 1 record, 2 records, 6 records, 4 records, 1, 1, 1. Total how many records are there? 16 records are there. Out of 16 records, where the median will be there? For 16 records, where the median will be there? In the 8 and 9. Between the 8 and 9 it will be there. Where 8 and 9 records are there? In the this one. Means your median value will be here or where? In this particular bar. Your median value is located inside this bar. So see completely clearly. What is your median value? 28.5. 28.5 will be located in which bar? 20 and 30 bar. So your median is located here. Your median is located here. So your median is more or mean is more? Mean value is more here. 30 here center value. And this is wherever the median value is located. So here median is located in this, mean is located here. So median is less than the mean or mean is greater than median. Anything. Choice is yours. So mean is greater than median. It is considered as right skewed. Point is clear? Sir, in a simple words to remember, tell me, sir. Okay. Now see, I will remember in terms of wherever the median is there, median in the big bar for remember purpose, guys. Okay, for remembering only. This logic is only for to remember easy way. So I'll take here directly opening only very big bar I'll take. And remaining all of them I'll take the small bars only. So obviously wherever the big bar is there, automatically it will be considered as median. So my median is here, but from here to here mean will be always in the center only now. So here I will write the median, mean, and this is my median, and I will conclude automatically this one as right skewed. Right side less number of data are there. Now same example, when I take for the remembering purpose, okay, small data I will take on the left side. Right side I will take the big size of bar, something like this. Now center means from here to here, center means obviously here only will be there. This much of length is there means in this length where the center position will be there. So I'm going to take the center position. If required, I will not write this one also. Okay, this is my mean. Where my median is located? Wherever the big bar is there, that one. Now median is less than the mean or median is greater than mean? Means it is less than, because first you will get the mean value. After getting the mean value only, you will get the median value. In the x-axis, what are the dots you are going to write? First m will what are the mean is there, it will come. After that median value is coming. 0, 1, 2, 3, 4, 5, 6 you'll write like this now. 1, 2, 3, 4, 5. So first 5 with here I assume this is 6 number or 7 number. First mean has came and automatically 8. This is median. Now which one is big, which one is less? Miss median is big, mean is less. So mean is less than median is considered as which type of skewed? Left skewed. Left side less number of data is there. In this example, right side less number of data is there. I will take only one bar in the maximum height, remaining all of them in the small height for my remembering purpose in my brain, so that easily I can remember this one. Is the point is clear? Everyone? See, don't take based on this example, don't conclude that wherever the big size of bar is there, that one only median. That is not my meaning. To remember only one, I am taking the big one, remaining all of them I am taking the small one. Means, for example, here one record is there. Let's take an example. One record, one record, one record, one record, one record, one record. Okay. Here 10 records and one record. Now total how many records are there? 1, 2, 3, 4, 5, 6, 7, 17 records. For 17 records, what is the median value? For 17 records, what is the median value? Ninth record is going to be the median value. For 17 records, ninth position is going to be the median. 9 means where it will come? 1, 2, 3, 4, 5, 6. Already 6 is completed. Ninth record where is there? Obviously in this big one only it should be there now. Ninth record where it will be located? 6 records are completed. First 6 records are completed in the ascending order. And after that, ninth record. Where the ninth record will come? Is the point is clear now? Everyone? Yes or no? Now, this is with respect to Y column. For the Y column, I am going to apply the last one. What is the last one is KD plot. So, I am applying the SNS dot KD plot on Y column. And when I observe the Y column KD plot, can you see right side? Okay. Now, coming to this. Yes, we have to measure for each of them. When you are working on a real data set, you have to calculate for each of them. For every column, you have to do everything. Every measure has to be applied. Okay. If based on the requirement. Based on the requirement. Now, so right skewed, generally how the right skewed distribution data will be represented in the KD plot means like this. Tail. This is called as tail. What are the tail is there? Tail will be on the right side. Sir, why tail will be on right side means right side less number of records are there means automatical tail will come on the left side only. Na? This is the diagram, right? Histogram will be like this. And here as the right side, you are having the less number of records. Okay. Now, for example, if your tail is on left side like this, what is the meaning? Left side, you are having the less number of records. Tail means, what is the tail? Tail means the height. Is the point is clear? Left tail is there means it is left skewed distribution. Right side tail is there means it is right skewed distribution. Left tail left skewed distribution. Right tail right skewed distribution. Tail means less number of records. Same logic now you apply on the Z column also. For Z column, if you apply this one, and for Z column, if you see the mean and median, let's apply the mean and median on the Z column. What are the mean values there? And along with the Z column, median also. Again, now tell me, mean is more or median is more? First one is mean value followed by median value. So mean is less than median. When mean is less than median, what is called as left skewed. And from the skewness also what you have got? Minus, which is left skewed. This is also concluding left skewed. This is also concluding left skewed. Is the points are clear, guys? Everyone? Yes or no? And KD plot is also clear, right? So KD plot will give the curve, the line plot, some kind of line. And from the KD plot, what is the advantage you are going to have? Only one advantage called as whether it is right skewed or left skewed. Sir, instead of KD plot, in this only can't we bring the KD also? What are the histogram we have drawn? Now here only we can bring the KD miss just by adding the KDE is equal to true. If you write like this, automatically your histogram will be available. At the same time, this one also will be available. In the hist plot only, just add the KDE is equal to true. If you don't add the KDE is equal to true, by default it will take the false. You can have the separate KDE plot, or in this only you can have the KDE is equal to true. Is that clear, everyone? Yes or no? If it is not clear, please ask. What are the questions you are having? Right, guys? Now, next, after completing this KD is equal to true and everything, that is plots. Okay. Next, as already I told you the how to check the whether the given data is normally distributed or not. Now, let's have a small recap of what are the things we have covered till now in the statistics. Within the measures, population sample, all you know. Types of variables, you know. I'm not discussing that one. Just I'm writing the measures. First measure is mean. Second measure name is called as median. Third measure name is called as mode. Right? Now, what is the use of, one of the student is asking, Govardhan Reddy, what is the use of skewness? So, based on the skewness, if you are having the right skewed or left skewed, we can't apply the inferential statistics. Statistical tests we have to apply now. That you have to convert after converting to normal distribution only. Skewed data we cannot work. The advantage you will see now. Govardhan, just wait for another 5-10 minutes. You'll understand the advantage of skewed data and normal distributed data. Okay. So just now, what are the measures we have completed till now? I'm writing all the measures, all discussed till now. What are the various measures like mean, median, mode, followed by minimum value, followed by maximum value, followed by range, right? Then I told you after completing the range, what is deviation? After explaining the deviation, mean deviation. After explaining the mean deviation, next I have explained for you the square deviation. After this, I have explained for you mean square deviation. Mean square deviation. After this, mean square deviation is also called as variance. Next, I have discussed with you standard root mean square deviation. What is the problem with that and how it was rectified means by adding the root. Root mean square deviation, and which is also called as standard deviation. After explaining this one, next I told you the Bessel correction. What is meant by Bessel correction? Okay. After completing the Bessel correction, we have moved on to the percentile. And based on the percentile, I told you the quartiles. And using the quartiles, I told you the IQR. Once you have understood the quartiles, Q1, Q2, Q3, Q1, Q2, Q3, and based on that IQR. And after explaining the IQR, I told you how to calculate the lower limit and also upper limit. Okay, that is nothing but lower limit is nothing but Q1 minus 1.2 into IQR. Upper limit is nothing but Q3 plus 1.5 into IQR. Right? After explaining the lower limit and upper limit, next I told you the outliers. What is outliers? How to extract the outliers and how to check the outliers. I have explained for you the box plot. Before explaining the box plot, I told you the 5-number summary. 5-number summary, which is nothing but minimum Q1, Q2, Q3 and maximum. And using these 5 numbers, we are going to represent the box plot. Box plot will represent these 5 numbers along with the outliers. It represents the 5 numbers. What are the box plot is there? It represents the 5-number summary along with the outliers are available or not. It also tells whether outliers are available. Outliers are available or not by showing the dots. Now, after this, I told you the in terms of next one called as probability. Right? Now, what is probability? And after explaining the probability for discrete variable and continuous variable separately, to how to calculate the probability when data was given. Calculating the here I have explained first calculation of probability for discrete data when data was given. When data was given by writing the condition, probability of condition is equal to number of records satisfied your condition divided by total number of records. Similarly, I have explained for you the calculation of probability of for continuous data when data was given. Okay, and after this I have explained for you the distribution. What is meant by distribution for continuous variable, for discrete variable. From there I went to the frequency distribution. In the frequency distribution, I told you in terms of continuous frequency distribution and discrete frequency distribution. First we have covered the discrete frequency distribution and I also covered the continuous frequency distribution. Now what are the continuous frequency distribution is there? This is nothing but called as histogram. And discrete frequency distribution is called as count plot. Okay, before frequency distribution, I told you the frequency table. What are the frequency table is there? The frequency table followed by I have explained for you the frequency distributions. After explaining the frequency distributions, I told you what is different types of frequency, continuous frequency distribution means. One is called as uniform. Next one is called as symmetrical, which is non-uniform, symmetrical. And also next I have told you the skewed. Total 3 types of distributions will be there within the continuous. Whether these 3 are applicable on the discrete variable? Whether these 3 are applicable on the discrete variable? No. They are applicable only on the continuous because the bars has to attach each other. These 3 are a part of the continuous only. They are not the part of discrete. Okay. And after explaining the 3 types of distribution, symmetrical distribution, skewed distribution. Symmetrical distribution is also called as normal distribution. And from there, I went with the discrete probability distribution. Instead of frequency distribution, I have explained the probability distribution. right? And within the probability distribution, I have explained for you the discrete probability distribution and how to make the plot. Just you have to add the stat is equal to probability. And also I have explained for you the continuous probability distribution. Right? Continuous probability distribution. Now also along with this, I have explained for you the cumulative distribution. What is meant by cumulative? Cumulative means it's a combination of multiple intervals. Right? So these are the things were covered. And in the today's class, we have covered in terms of skewness, and also along with the skewness, how to check whether the data is normally distributed or not. These are the things are covered till now. Right? Everyone is clear? These are all the part of statistics. Right? Anyone? Any questions? Now, if you clearly observe, we check the calculation of probability for continuous data when data was given. Here, now we are going to work on the next concept called as calculation of probability for continuous data when data was not given. So without data also we can calculate the probability. Without the data also we can calculate the probability. Sir, how? That is the point. The next concept which we are going to call as z-score. Next concept is called as z-score, and which is used to calculate the calculation of probability for continuous data when data was not given. Next one is called as z-score. Now what is z-score? Z-score means converting a value to x minus mu divided by sigma, where this is the value, this is the mean, and this is standard deviation. Is the point is clear? Converting the values, converting the each and every value to corresponding z-score. This is called as z-score. Z-score, x minus mu divided by sigma. X minus mu divided by sigma. Now, converting every value to corresponding z-score is called as standardization. Converting every value, converting every value to corresponding z-score is called as standardization. Converting every value to corresponding z-score is called as standardization. Now, so here this is z-score. Z-score formula I have told you. and converting every value is called as standardization. Now next point is calculation of probability for continuous data when data was not given. When data was not given, they have to clearly give us normal distributed data only. Now it should be a normal distributed data. First point. Second point, they will give the mean value and standard deviation value. Based on these three values, we are going to calculate the probability. What are the three? First, they have to write the data was normally distributed along with the mean of this much, standard deviation of this much. Then only we can do the probability. Calculation of probability can be done. Point is clear? Now, so here I am writing the in a class an exam was conducted and marks of the students. What are the marks are there? Marks of students form a normal distribution. Form a normal distribution with a mean of 60 and standard deviation of 10. Okay, this is the data. Marks of students forms a normal distribution with mean of 60 and standard deviation of 10. So here how many students are there? Whether they have mentioned? Student marks they have mentioned? No. Students, number of students we don't know. Students marks also we don't know. But still we can calculate the probability of marks less than 90. What is the probability of marks less than 90? Marks less than 90 means how generally we have to calculate? How many students are there with less than 90 divided by total number of students. But here marks are not there, total number of students are not there. For example, if they have given like this 85, 90, 92, 98, 81, 92, 84, 76, something they have given like this. Now how many students are marks less than 90 means I can calculate. How many records are there less than 90 divided by total number of records? It is simple. But they have not given the data to me. How many students are there also they have not given? Everything they have not given, but they are asking to calculate the probability. Is the point is clear? Now, first I'm going to draw the normal distribution data. Your normal distribution data is characterized by mu and sigma. Any normal distribution data is characterized by, means it will be represented by. It is represented by mu and sigma. How it is represented? Please don't write in the notes simultaneously, just focus clearly. How it is going to be means, so first here in the center you have to write the mean. After the mean, next number, right side some number you have to write now. For example, in the 30 to 40, 40 to 50, you will write like this, right? How you are going to decide the next number means, the next number should be the mu plus 1 sigma value. You can't take as per your choice. It should be mu plus 1 sigma. Second one is mu plus 2 sigma, followed by mu plus 3 sigma. Left side, mu minus 1 sigma, mu minus 2 sigma, mu minus 3 sigma. So your what are the normal distributed data? Bottom part, the distribution. Bottom part, what we call as distribution. What are the distribution of the data is there? That distribution of the data should be with respect to these numbers. And this is your normal distribution data. As I have told you, how the normal distribution data curve will be looking as bell curve. Means exactly in the center position, you have to get the perfect shape like this. Is the point is clear? Now your normal distribution data is characterized by mu and sigma. That is the meaning. Is that clear? Why it is characterized by mu and sigma means the distribution of the data we have to give the mu value and sigma value. Now here in this question, what are they have given to us? A marks of the students forms a normal distribution with mean of 60 and standard deviation of 10. Marks of 60, average value mu. What is the mu value? 60. What is the standard deviation value? 10. So now what is the bottom values we have to write? First number. What is the first number? 60. What is the next number? What is the next number? What is the next number? Left side. Next. Next. And this is the diagram. So whenever you see the question, what is the first step you have to do is you have to draw the diagram. Once you have drawn the diagram, after drawing the diagram, we are going to calculate the probabilities. Is the point is clear? Now how we are going to calculate the probabilities means by using the z-score and z-table. Z-score and z-table. Remember this. Now how we are going to calculate? So just everyone please make a note of this. Marks of the students forms a normal distribution with mean of 60, probability of standard deviation of 10. Now question number 1. What is the probability of marks less than 90? What is the probability of marks greater than 90? What is the probability of marks less than 80? What is the probability of marks greater than 80? What is the probability of marks between 60 to 80? What is the probability of marks between 50 to 70 or 50 to 80? What is the probability of marks between 54 to 66? These are all the questions. Let's try with all the examples. Each and every example, let us try. Right? Main one is this one only. Internally question. These are all the questions one by one. Main thing is this. Is that clear? Let's start doing this one by one. Now similarly you have to do the other questions. Once I'll explain one question, similarly you do the second question. So whenever they have given the, sir, for example, if it is normal, not normal distribution, this logic we can't apply. If it is not normal distribution, if it is skewed data, we can't do the probability calculation. What I am explaining now, it cannot be done. Is the point is clear? It can be done only when it is normally distributed. Clear? Now, coming to the first, after seeing the question like this, what is the first step you have to draw means draw the diagram. That is the first step. Draw the diagram. What is the diagram? Center 60. After the center, right side, how much value you have to add? Mu plus 1 sigma. What is mu? 60. 60 plus 1 into sigma. What is the 1 into sigma? 1 into 10. 1 into 10 means 10. 60 plus 10. 60 plus 10 is 70. Next, mu plus 2 sigma. What is 2 sigma? That is 2 into 10. That is 20. 60 plus 20, which is 80. 90. 100. Okay. Followed by 50. 40. 30. 20. Is that clear? Now, so this is the normal distribution, and make sure exactly you are going to get the peak at the 60. This one, what are the peak is there now? This one should be exactly at the 60. And it should form the normal distribution, that is symmetrical. Make sure the diagram is like that. Okay, guys. Now, next one is, what is the question is, first question, marks less than 90 means they are asking the cumulative probability from minimum to 90. Do you remember yesterday cumulative probability we have discussed? What is cumulative probability? Starting to. Less than 90 means what is the meaning? Minimum value to 90. So this is the probability which they are asking. Now, greater than 90. What is the meaning of greater than 90? 90 to the maximum. What are the maximum number is there? That number. This is the one. Now they are asking greater than value or less than value or less than value. So what, left side area or right side area they are asking? Left side area. Is that clear, everyone? First point. Whenever you are saying the less than symbol, it is left side area. Whenever you see the greater than symbol, it is right side area. Point is clear? Now, what are the left side area you are having? That is less than 90, right? Now, how I am going to calculate means, first, for which one they ask the probability, that is marks less than 90. This is the one. First, I will calculate the Z score at 90. Why 90, sir? Because they ask the probability for less than 90 now. For 90. Z score of 90 is equal to x minus mu divided by sigma. Now, what is the x value? 90. So, I am going to substitute 90 minus, what is the mu value in the question? 60. What is the sigma value? 10. So, 30 divided by 10, which is 3. So, Z of 90 is equal to 3. Everyone is okay? Right? Now, after getting this one, Z of 90, now what you have to do? Open the Z table. What are the Z table is there? z-table.com. So you have to open the Z table. Now in this table, you are going to have the probability values. These are the probability values. This is the Z table and this is the probability values. Now you will get a question. How to understand this table? I'll explain one by one. Now what are the Z score you got now? Some Z score. What is the Z score you got? 3. So for example, instead of Z score 3, let us assume you got the Z score as minus 3.41222, something like this. Let's take an example. Here in your case, you got a round figure number minus 3 easily. Let's take an example, something you got the 3.4122. Now what are the 3.4122 is there? First you make the 2 decimals. How many decimals? 2 decimals. That is round figure to 2 decimals. What is the value? 3.41. Point is clear? Now here 3.41, what are the is there now? First up to 1 decimal you will find here. Your second decimal is here. Now by combining these two, what are the number is there? That is the probability. Logic is clear? Everyone. One more time. One more example. Now, for example, your Z score. Z value minus 2.944. Up to how many decimals you have to make first? 2 decimals. Now, what is the round figure of 2 decimals? 2.94. That is okay. Up to 2 decimals round figure. Now, first up to 1 decimal, where you have to see here. In this one gives the 1 decimal. Second decimal gives this one. This is your second decimal. Now tell me 2.94 means up to 1 decimal. Where what I have to take? 2.9. This line. This is okay for everyone. 2.9 means this line. Okay now? Now, what is the second decimal? 4. Where is 4? This one. Now, these two combiningly, which value is getting combined? 0.0016. That is the probability. Point is clear? Clear or not clear? Now, clear now? Now, what is your value? You got 3. Up to 2 decimals. Up to 2 decimals, what you have to do? 3.00. Okay. Now, up to 1 decimal, where you will find? In the this side. This second decimal, where you will find? Here. Now, can you 3.0 plus or minus a? Plus. Here it is a minus a plus a? Minus 3.0. No, come down. Up minus 3.4, minus 3, minus 2, minus 1, 0, 1, 2, 3, like this. Come down. So see here, minus 3.0, minus 2.0, minus 1.0. After that, finally 0. Still scroll down, move down. Can you see here? 1, here it is 2, here it is 3. So now what is your value? 3.00. 3.00 means first decimal, this one. What is the second decimal? 0 only. That is nothing but this one. This is 0, 0. So can you observe here 0, 0? Second decimal. So now what is the value? 0.9987. That is the answer. Simple. What is the probability less than 90 means? 0.9987 is the probability. Completed. Question 1 is completed. Now, question 2. Let's go to the question number 2. Now, question number 2. What is here? Symbol? Greater than. Whenever you are having the greater than symbol, it is equal to 1 minus probability of marks less than 90. Sir, why we have to do 1 minus, sir? Directly we can't calculate greater than? No, because here what are the probability you are going to receive from the Z table? This is left side area or right side area? Can you see here? Area, complete area, left side. Now, if you go with this one, negative values or positive values, every time you are going to get the left side area. Left side area means less than area or greater than area. This is your number. Assume this is your number 60. Less than 60 you are getting or greater than 60 you are getting. So every time less only. So in the Z table, always you will get the left side area only. Then how to get the right side area means 1 minus. Why, sir? Because total area is equal to 1. Why total area will be 1 means sum of the probabilities. Now, area means nothing but probability. Area means probability. Total area is equal to 1 means sum of the probabilities is equal to 1. That is the meaning. Point is clear? Now, everyone, now it is done, completed. So already you know what is the value of 1 marks less than 90. 1 minus that one is marks greater than 90. Is the point is clear, everyone? Now, let's calculate for marks less than 80. Okay, greater than 80 is nothing but what? 1 minus marks of, what is the probability of marks less than 80? 1 minus. This is equal to 1 minus probability of marks less than 80. Now, first one is probability of marks less than 80. Let us calculate. How to calculate probability less than 80? What is the first step? 80. For 80 you want. Z of 80 you have to calculate. How to calculate Z of 80? 80 minus 60 divided by 10. What is the value? 2. That is 20 by 10, 2. Now for 2, what is the probability value? Open the Z table and tell me for probability, what is the 2 value? Where is the 2 value? What is the probability of 2 value? 2.0 is 0.9972. But my requirement is what? 2.00. That is nothing but this one only. Is that clear? Everyone. What is the probability of X marks less than? What is the probability of marks less than 40? Let us add one more question here. Now you tell me. You only do everything and you only check that G table. You only tell me the value also. Open your mobile phone and open the Z table and you only calculate and you only tell me. Sir, this has to be done manually, miss? Yes, in the certification manual, in the internal company coding. I will show you the Python code also for this. First, let us complete manual. What is the probability? So marks less than 40 is nothing but for 40 Z score we have to calculate 40 minus 60 divided by 10, that is 20 minus 20 by 10, which is minus 2. And in the Z table, wherever the minus 2 is there, just if I open my Z table, minus 2, it is nothing but 0.0228. This is the answer. This concept where you will use, that is next. One by one. Just now in the previous one of the student, Govardhan Reddy has asked the question, where we'll use the normal distribution. Now using this, all the things are applied only on the normal distribution data. Now what is the use of this one? We'll discuss one by one. First we are going to see the measures. After the measures, we'll discuss the analysis. Let us complete the measures. Automatically you'll understand. Sorry, X greater than 80, 60 to 80, these questions also will cover. Greater than 80 is clear now. Greater than 80 means 1 minus this one. Now next, let's move on to the next examples, that is 60 to 80. Now let us see how to calculate 60 to 80. Always I told you, first what you have to draw? Diagram. Okay. Now after drawing the diagram, now exactly at the center, 60 is there, 70, 80, okay, left side, 50, 40, 30, or what are the numbers, right? You are having something like this. Now, what is the question they asked is, what is the question? 60 to 80. 60 to 80 means from here to here. This is the area. Observe this very clearly, guys. Hold. Don't write along with me. Just observe. 60 to 80 is the area. Now, for example, if I calculate probability less than 60, what area I am going to get? What area? That is starting to 60. Is that clear? Everyone is okay with this? Now, when I calculate the next question, second question, when I calculate the probability x less than 80, from where to where? Again starting to 80. This point only important. Again starting to 80. Now my requirement is 60 to 80. Then what I have to do? Blue color area minus black color area. Automatically what of the balance will be my requirement. Point is clear? So probability of 60 to 80 is nothing but probability of x less than 80 minus probability of x less than 60. The reason is this one. Just observe, and if you are having any question, please ask. Clearly ask. Starting to 60 I calculated, starting to 80 I calculated. So starting to 60, I don't want in the 80, already it was calculated now. So balance part I am considering. Simple. Now only thing is you have to calculate for this one, you have to calculate this one separately, and then you have to do the minus. Now tell me, what is the area between 50 to 80? What is the area between 50 to 80? I mean 50 area or probability, both are same guys. What is the answer? Probability of x less than 80 minus probability of x less than 50. Now I want the probability between 66 to 94. What is the answer? Probability of x less than 94 minus probability of x less than 66. Like that, from where to where you want, you can calculate now. Clear? In the notes, please clearly write like this. Probability of x less than 60 was represented by black color. Probability of x less than 80 was represented by blue color. And the probability of 60 to 80 was represented by pink color, this one. Any question? Greater than 90. Yeah, greater than 90 means 1 minus less than. Left side area you get now. So total, what is the total area? What is the total area? What is total area means? What is meant by total area means? Total probability. Total area means nothing but total probability. What is total probability? Sum of the probabilities are equal to 1. In this, already from here to here it is 0.8. What is the balance will be? 0.2 only now. So if the area less than 90 is 0.8, then what is the area greater than 90 means? 1 minus 0.8 only, right? Clear? Just yesterday cumulative probability table you have taken now. Open the cumulative probability table in your notes, which is having the cumulative probability table. Okay, in that table, just tell me in your table, as per your table, probability of x less than 60. X less than 60 means starting to 60. What is the answer? 6 by 16, right? What is the probability x greater than 60 in that case? In the same example, less than 60 you told or greater than 60 you told? Just now you told one number now, 6 by 16. What is that? You told for what? Question. X less than 60, it is 6 by 16. Starting to 60, it is 6 by 16. Now, what is the probability of x greater than 60? Greater than 60 means from 60 to everything. Calculate from 60. In the table, you calculate. Open. Table is there. In the table, 60 to 70, 70 to 80, 80 to 90, 90 to 100. Total, do that. What is the total? Greater than 60, I am asking. X is less than 60 means 30 to 40, 40 to 50, 50 to 60. You are combining these three, which is 1 by 16, 2 by 16, 3 by 16. Total is 6 by 16. Now, when I'm asking here greater than 60, you have to take 60 to 70, 70 to 80, 80 to 90, 90 to 100. A combination of these four. 60 to 70 is 4 by 16, 3 by 16, and 2 by 16, and 1 by 16. What is the value is 10 by 16, which is also called as 1 minus 6 by 16. Is that clear now? Yesterday's example, if you open and you can get the answer clearly. Everyone, completed? Everything is clear now? How to calculate for the interval probability also is clear now? By using the Z table? Yes or no? If it is not clear, please ask. What are the questions you are having? So in this example, when we are going to use this one means when they have not given the entire data. Without giving the data, they are simply giving this one. For example, 10,000 students are there. 10,000 students marks are there with you. And calculating a probability from using the 10,000 records is easy, or if they give the mean value and standard deviation, it is easy. When you take the large amount of data, you will see the advantage of this. When you are doing the manual calculation. When you are using the Python or something else, that is different. Manually, when you are having the 10,000 data with you, and in that 10,000 data, you have to do the calculation, means it would be difficult. For that reason, they have created this one. The statisticians has invented. Now, what are the Python codes you are seeing? The latest one. But this is the old one. Now, okay, sir, this is old one, fine. Latest one is Python. In the Python, we'll get the answer easily. Why you are explaining the old one to us now? Latest one only now, because we are in the 2024, 25. So we require the latest one only, right? Why we are discussing the old techniques with us means the reason is very simple. In the certification exams, they'll give this one only. Is the point is clear? They'll give this one along with the Z table. Sir, Z table also they'll give. Z table also they'll give. How they'll give the Z table, sir? ZW means books will be shared or something. No. In the certification, they'll cut this box. For example, your requirement value is somewhere here. Instead of giving the entire data, they will give in the question from here to here. In that, your value also will be available. Is the point is clear? In the question, along with the image also they'll add. In that image, these values will be there. In that, one of the values yours. Your required values will be. Is the point is clear, guys? They may not give the entire data. Now, coming to the next one. Now, everyone please start doing the calculation. What is the probability of 60 to 70? I want fast. I am giving you 1 minute of time. Probability 60 to 70. And similarly 50 to 60. These two questions. Now, fast. 1 minute. Completed? What is the answer? 4, 413. 0.44. No. 34. Exactly. It is not 44. It is. Okay. Yeah. So if I take the round up to 2 decimals, 0.34 is the answer. And what is the probability of 50 to 60? Everyone please calculate probability from 50 to 60 also. Completed? Completed, guys? What is the answer? Same answer. Once again, it is 0.34. Now, question number 2. One more time. Guys, make fast calculation, please. In a class, there is a normal distribution data. This time, the mean value is 70 with a standard deviation of only 5. Now, what is the 70 to 75? In this is the case, 70 to 75. What is the answer? And what is the answer for 65 to 70? Completed. What is our value? Again, it is 0.341. Okay, up to 3 decimals if you consider 0.341, or if you consider up to 2 decimals 0.34. 65 to 70 also, it is going to be the same. Now, from this, what we are going to conclude? Why I asked you to do this one means, so here one concept is there. When you are having the center mean value, whether it is 60, next value, for the example 1. Okay, example number 1. Ishwar Satish. Sir, once explain, sir. Which one? Ishwar Satish. Which one? Probability of 60 to 70, how it is 0.34, right? Right. Other than Ishwar Satish, still, how many of you are having the question of how to calculate the probability of this one? Raise your hand once. Both offline and online students, other than Ishwar Satish. Online students? Just, okay, guys. So just I'm adding one more time. So all the question, only the raise hands only from the online students. There is no offline student. Fine. Okay. All the students who has raised the hand, please observe this. How to first observe this question. Mu value was given as 60. Standard deviation was given as 10. Okay. And I'm drawing the diagram. Always first I will write the given data along with the diagram. This is my first step, always. Okay. Now my requirement is probability of 60 to 70. 60 to 70 means here they are asking the question between this one to this one. This is the area which they are asking. Okay. Up to here everyone is clear? Question is clear first. Mu value 60, sigma is equal to 10, and this is the area. Now here what I am going to calculate means first probability of x, that is 60 to 70. What are the probability they asked? Which is nothing but probability of x less than 70 minus probability of x less than 60. Okay. Now why it is less than 70 minus why it is less than 60 means, see, less than 70. What is meant by less than 70 means from the starting. What are the starting is there? From the starting to 70 you are going to get. Less than 60 means from the starting to 60 you will get. Again from the starting to only 60. Now blue line is up to 60. Pink line is up to 70, but I want the black one. How to get the black one? Ishwar Satish. I want the black area. Okay. See, this much of blue area is there. This is completely blue area. Along with the blue area, or let me draw like this. This is blue area. Ishwar Satish, tell me this one. This is blue area. What are the blue area you are having? This is blue area. Okay. Now you are having one more area called as pink area, which is a combination of blue along with the gap. This is completely blue, pink. Blue is there along with the completely pink also. Now I want this one. I want this portion only. I don't want the blue portion. I want only this one. What I have to do? What I have to do? Ishwa Satish, subtract. What you are going to subtract? What you will subtract? Big area minus small area. Is that clear? Satish, is clear now? Now, how to calculate the probability of x less than 70? Let us calculate separately for x less than 70 first. That is z of 70. Z of 70 is nothing but 70 minus 60 divided by 10, which is 1. Now from Z table at 1, z at 1, what is the value? What is the probability value at z is equal to 1? 0. Sorry. At z is equal to 1, what is the value? 0.8413. Now z of 60, that is probability of x less than 60. 60 minus 60 divided by 10, which is 0. Now at a z of 0 from the z table, what is the p value? 0.5. Now from these two, what is the finally value of p less than 70 means 0.8413 minus 0.5, which is 0.3413. Is that clear now? Satish, is clear or not clear? This is from Z table. From Z table, this is the value. This is from Z table, this is the value. And since you got two values, just you are going to subtract the bigger one minus smaller one. Others, whoever has raised the hand, is the question is clear? Everyone, anyone has any question, please ask one more time. If you are having the question, please ask. Okay. So today you are going to practice some more examples based on this. How to calculate the area when mean and standard deviation was given along with the normal distribution. Mean and standard deviation along with the normal distribution when it was given, how to calculate the probability. Try with some examples more of your choice. Now, please complete this question. This is the last example. Yeah, I'm going to share you the example. In a class, number of students makes the normal distribution with marks of 70 and standard deviation of 10. Standard deviation of 10. What is the probability of 70 to 80 is the question 1. Probability of 80 to 90. Probability of greater than 90. Or 90 to 100. Next, probability of 60 to 70. Probability of 50 to 60. And what is the probability of 40 to 50? Okay. Just a minute, guys. I'm writing clearly. First question, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. It is better now. question will be better. 40 to 50, what is the value? 50 to 60, 60 to 70, 70 to 80, 80 to 90, and 90 to 100. All these 6 questions, try to complete, and from here we'll continue in the tomorrow's class. Okay, keep this example standard in your notes. Tomorrow, this one is important. If this answer is there only, we can continue in the tomorrow's class. Remember, you will understand tomorrow's class when you solve this answer. If this is not clear, tomorrow class will not be clear and you will not understand the importance. Okay, done. Others, you can leave. If you're not having any questions, you can leave. Yes, Sheikh is asking the question. Sir, in the table it is having only minus 3.49 to plus 3.49. If it is crossing more than that, what happens? See, very simple, Sheikh. So here, if you are having the maximum value other than 3.4, any value more than 3.4, the value is almost 0.0001, which is negligible, close to 0. Any value crosses more than this is 0, literally. Okay, because it would be less than this. Already three digits are 0. Fourth digit only 2 is there. More than this, what happens? Any value crosses more than minus 3.4, it is considered as 0. And any value crosses more than 3.4, this value is already 0.9998. Next number is going to be 1. Okay. Next. Others, you can leave. If no questions, you can leave. Please complete this question. And from here, we'll continue in the tomorrow's class.